Have you ever pushed your body, like, truly to its limit in training?
Yeah.
Felt that deep fatigue right down to your bones.
Oh, yeah.
And thought there has to be a smarter way.
Yeah.
You know, a way to bounce back faster, stronger, really ready for that next session.
Absolutely. That feeling is universal for athletes.
What if there's a cutting-edge technique, something that could fundamentally enhance how your body recovers?
Yeah.
Almost like finding a biological shortcut.
That's the dream, isn't it?
Well, welcome to the Deep Dive. Our mission today is to cut through the noise, really extract the key insights from a pretty groundbreaking scientific study. We're zeroing in on a paper titled Effects of Acute and Repeated Ischemic Preconditioning on Recovery from Muscle Fatigue After High-Intensity Swim Training in Male Amateur Swimmers.
Quite a title, but important stuff.
It is. And this research was done by Ying, Zihan, Zhou Wang, Jiawei LV, and Nan Yang. It's fresh off the presses, published this year, 2025, in the Journal of Sports Science and Medicine.
That's right. Volume 24, pages 696 to 706 for those wanting the specifics. Published online September 1st.
Exactly. And we picked it because it tackles, well, a core challenge for athletes everywhere.
Right.
Recovery. How to do it efficiently.
That's right. For any athlete, really, but maybe especially swimmers doing high-intensity work, managing that training load is just critical.
Yeah.
High-intensity training, you need it for gains, but it inevitably leads to rapid muscle fatigue. And it's not just feeling tired.
Right. It's more
It involves, metabolic byproducts building up, localized oxygen deprivation, hypoxia, we call it.
Right.
And that often leads to oxidative damage, inflammation. It's a whole cascade.
Yeah, and that hits your immediate performance, but also your long-term health.
Absolutely.
Well, impacts both.
I think anyone who's ever really pushed themselves in sport instantly gets that deep, lingering fatigue. You're just desperate for something to help you bounce back.
True.
And athletes, they have their usual methods, don't they? Like low-intensity swims, stretching.
Massage, foam rolling.
Yeah.
Yeah, the common ones.
Exactly. And look, these external methods are popular for a reason. They do offer some relief, relax muscles, maybe improve flexibility a bit.
Sure.
But as this study kind of reinforces, they don't always get to the deeper physiological issues driving that fatigue, the core stuff.
Exactly.
Like energy depletion inside the muscle cells themselves, significant oxidative stress, that whole inflammatory response that follows hard exercise.
Okay.
Cold water immersion, CWI, that's another one swimmers use. It's known to be effective for fatigue and inflammation.
Right, the ice baths.
Yeah, the dreaded ice baths. But, the big limitation there is often equipment, facilities.
Yeah, not exactly practical for everyone after every single session.
Exactly. Not everyone has a giant ice bath handy, which really highlights this need for simpler, more accessible methods. Things that work with the body, harnessing its own systems.
And that brings us neatly to the star of today's deep dive. Ischemic Preconditioning,
Right.
IPC. Now, the name sounds a bit technical, but the concept is genuinely fascinating. It was initially looked at in cardiology, right, for heart protection.
That's right, yeah, which is interesting context.
So can you break down the basic idea of IPC for us? What is it?
Okay, so think of IPC like giving your blood vessels a tiny, controlled stress test.
Okay.
You briefly, gently squeeze off blood flow, that's the ischemia part, usually with a cuff, like a blood pressure cuff on a limb.
Got it.
And then you let the blood flow rush back in, that's reperfusion.
Squeeze and release.
Exactly. And you do this in short cycles. It's not just random. These repeated little squeezes and releases actually seem to train your body. They make it more resilient for when it faces a bigger stress.
Like a really hard workout.
Like a really hard workout or even certain medical situations.
So it's like prepping the body with a controlled mini challenge first. How does that work? Like what's happening inside at the cellular level?
Yeah, this is where it gets really cool. The body's response is quite smart. These brief cycles of essentially oxygen lack and then restoration, they trigger the body's own protective mechanisms, endogenous protection.
Ah, okay.
So it stimulates your natural antioxidant enzymes, boosts production of other protective compounds, and it modulates key cellular signaling pathways.
And the result is?
The result is you get less oxidative stress and less inflammation than you normally would from a big ischemic event, or in this case, from intense exercise. It's really about harnessing your body's built-in defenses.
That's incredible. Using a small stress to prep for a big one. And it's not just theory anymore, right?
Yeah.
We've seen IPC used in sports.
Definitely. There's research out there showing potential benefits. Things like maybe increasing VO2 max, improving 100-meter swim times,
Wow.
even reducing inflammation markers in marathon runners, aiding recovery in cycling, tennis. It's been looked at across different sports.
And the key thing seems to be using it before the exercise, right? Like a preconditioning step.
Exactly. That's the typical application. You create this preconditioned state before the athlete starts their main high-intensity work.
Okay. And you mentioned swimming specifically. Why is IPC maybe particularly relevant there?
Well, swimming has some unique demands, physiologically speaking. You've got the horizontal posture, which changes how your cardiovascular system is loaded, how blood returns to the heart.
Right, different from running or cycling.
Totally different. Plus, swimmers often deal with intermittent hypoxia, brief periods of lower oxygen because of breath-holding patterns during strokes.
Ah, interesting.
So these things create distinct oxygenation challenges. And since IPC itself involves manipulating oxygen delivery, it seems like a really good candidate to investigate in that specific aquatic context.
Okay, so it makes sense why researchers would look at IPC for swimming. But this study, the one we're diving into, it carved out a specific angle, didn't it?
It did. While previous work looked at IPC and swim performance, this study focused specifically on fatigue recovery after intense swim training.
Ah, the bounce back factor.
Exactly. And crucially, they compared doing IPC just once acute IPC, or AIPC, versus doing it repeatedly over several days, repeated IPC, or RIPC.
And what was their prediction?
The hypothesis was pretty clear that the repeated applications, the RIPC, would be more beneficial for recovery.
Okay, so let's get into how they tested that. The study design sounds like it was pretty thorough.
Oh, absolutely. They used a really rigorous methodology. They recruited 30 male amateur freestyle swimmers.
Male amateurs, okay. Why that group?
Well, they were around 21 years old, had at least 2 years of solid training, national level 2 status, so trained but maybe representing a wider group than elite pros. And crucially, to isolate the IPC effect, none had used IPC before, and they had to avoid alcohol, caffeine, any supplements during the study period, really trying to control those variables.
Makes sense. Clean data. And how did they split them up?
Right, randomly assigned. 3 groups, 10 swimmers in each. You had the sham group, that's the control. They got a single intervention, but with a really low cuff pressure, only 20 millimil Hg, basically doing nothing physiologically.
Got it. A placebo cuff.
Pretty much. Then the AIPC group, they got one real ischemic preconditioning session. And the RIPC group got repeated sessions, one every day for 7 consecutive days.
And the real IPC, what pressure did they use?
Both the AIPC and RIPC groups used 220 millimil Hg.
Okay. In the actual cuff protocol, what did that look like? Was it just constant pressure?
No, it was cyclical. They had cuffs placed high up on the thighs while they were lying down relaxed. The protocol was 4 cycles, each cycle. 5 minutes of occlusion blood flow stopped, followed by 5 minutes of reperfusion blood flow restored.
So 5 on, 5 off times 4.
Exactly. Total of 40 minutes for the intervention. And they confirmed with ultrasound that 220 millimil Hg did fully block blood flow in the leg artery, while the 20 milliliter Hg in the sham group definitely did not. So proper control.
Okay, so they did the preconditioning, or the sham version. Then came the hard part, the swim.
Yep. 20 minutes after their intervention, whatever it was, all participants hit the pool for a tough workout. 7 sets of 200-meter freestyle. Incremental high intensity.
Ouch. How did they make sure everyone worked equally hard?
Good question. They individualized it. Each swimmer had target times for those 200s based on their own personal best 200 free time. So everyone was pushing relative to their own capacity, consistent intensity.
Smart. Okay, so they stressed them with the swim. Then came the measurements, looking for recovery differences.
Yeah.
What did they measure and when?
They measured a lot of stuff.
Yeah.
Very meticulously at 4 key time points. Baseline, before anything happened.
Right.
Then immediately after the swim training. And then again at 24 hours post-training and 48 hours post-training.
Covering that initial recovery window.
Exactly. And the measures fell into 2 buckets, external load and internal load.
External load being performance stuff.
Basically, yeah. Practical performance metrics, grip strength, upper limb total work. They used a special swimming ergometer for that. And lower limb power, specifically relative peak torque and average power from a knee isokinetic test. How much force and power the legs could generate.
Okay, that's the can you still perform aside. What about the what's happening inside part? The internal load.
Right, the physiological picture.
Yeah.
They looked at limb circumferences, checking for swelling, and then a whole panel of blood markers.
Oh, right.
Creatine kinase CK, that's a big one for muscle damage. Malondialdehyde, MDA, for oxidative stress.
Okay.
Then markers of the body's antioxidant defenses, glutathione, GSH superoxide dismutase, SOD, and total antioxidant capacity, TAOC.
So damage, stress, and defense.
Exactly. Plus, inflammation markers, interleukin-6, IL-6, and C-reactive proteins, CRP. It was a really comprehensive look at the whole recovery process.
Wow. Okay. A lot of data points. So after all that meticulous work, what were the big findings? What jumped out from the results? The aha moments?
Yeah, the findings were pretty striking, especially favoring the repeated IPC group. Let's start with external load, the performance recovery. The RIPC group showed significantly higher upper limb total work and also higher average quadriceps power compared to the sham group. And this wasn't just at one point.
Right.
It was at all the post-training time points, immediately after, 24 hours after, and 48 hours after.
Whoa. So consistent, superior performance recovery for the RIPC guys. They could just do more work sooner.
That's exactly what it indicates, a really robust effect.
What about the single session group, AIPC? Did they see any benefit?
They did, but it seemed delayed or maybe just less strong. The AIPC group only showed significantly higher upper limb work and quad power compared to sham way out at the 48-hour mark.
Ah, so a benefit, but took longer to show up clearly.
Seems that way. And interestingly, some other external things like grip strength and limb circumference didn't show significant differences between the groups, just changes over time, indicating general fatigue from the swim itself, which you'd expect.
Okay, so RIPC clearly wins on the performance recovery front. What about those internal markers, the blood work, what was happening physiologically?
Here's where RIPC really shone, showing a broad impact. Right after the swim, immediately post-training, the RIPC group had significantly higher total antioxidant capacity TAOC, better antioxidant defense right away.
Nice.
And importantly, they had lower levels of that oxidative stress marker, MDA, and the inflammatory marker, IL-6. And this was lower compared to both the AIPC and the sham groups.
So immediate protection against both oxidative stress and inflammation with RIPC. Did that last?
It did seem to. At the 24-hour mark, RIPC still had higher TAOC than the other groups. And really crucially, the RIPC group had significantly lower CK levels.
The muscle damage marker.
Exactly. Lower CK than the sham group at both 24 and 48 hours post-exercise, showing less muscle damage or faster repair.
That's huge. Did AIPC show anything on the internal side?
Yeah, AIPC also had some benefits. They showed lower MDA and IL-6 than the sham group at 24 hours. So it did something positive, just maybe not as quickly or as broadly as the repeated sessions. So the overall picture was really consistent. Both IPC methods helped recovery, both externally and internally. But RIPC, the repeated version, was just consistently and significantly more effective across pretty much all the key measures.
Okay, let's try and unpack that. Why?
Huh.
Why was repeated IPC so much better? And especially that weird remote effect, cuffs on the thighs helping arm performance. How did the researchers explain that?
Yeah, that remote effect is really one of the most fascinating parts. The researchers suggest a couple things are going on. First, IPC seems to have this biphasic protective window.
Biphasic, meaning?
Meaning there's an immediate protective effect, but also a delayed one that can actually last up to 72 hours.
Wow.
So doing repeated sessions like the 7-day RIPC protocol probably creates this cumulative effect. It builds up that resilience over time, leading to more profound and longer-lasting support for muscle repair and recovery.
Like stacking the benefits day after day.
Sort of, yeah. And about that remote effect, thigh cuffing helping the upper body. The idea is that IPC triggers the release of certain substances into the bloodstream, things like nitric oxide, which are vasoactive.
Meaning they affect blood vessels.
Exactly. They help dilate blood vessels. So these substances travel systemically and can improve microcirculation, tiny blood vessel function in tissues far away from where the cuff was applied.
So it's not just a local effect, it's systemic.
It appears to be. IPC might be training your body to release its own internal vasodilators, which then help blood flow everywhere, including active muscles that weren't directly occluded. There's also talk about enhancing functional sympatholysis.
Okay, breaking that down.
It basically means improving the body's ability to direct blood flow efficiently to working muscles during exercise, overcoming the normal constricting signals. Better oxygen delivery precisely where it's needed.
So a localized trigger leads to a smarter whole-body circulatory response for recovery.
That's the compelling idea, yeah. a localized stress prompting a systemic adaptation that benefits recovery everywhere. It's quite elegant biologically.
It really is. And connecting back to the internal markers.
Right, it all ties together. IPC boosts antioxidant activity, higher TAOC, GSH, SOD. That fights oxidative stress, lower MDA. And it modulates inflammation, lower IL-6, lower CK. This is key for swimmers pushing hard, where oxidative stress can really build up and worsen fatigue.
And practically speaking.
Practically, it's simple, right? Relatively low-cost cuffs compared to, say, cryo chambers or elaborate setups, much more accessible.
Definitely seems more practical than daily ice baths for those people. So let's bottom line this. What does this mean for you, the listener, especially if you're an athlete, maybe a swimmer?
Well, the big practical takeaway from this specific study is pretty clear. It strongly suggests that doing daily IPC sessions, maybe over a week or so, particularly leading into a competition or a heavy training block, could be a really effective, simple, and accessible strategy for male amateur swimmers to significantly boost their recovery and potentially improve their performance as a result. It looks like a powerful tool to add to the toolbox.
That is a really impactful finding. But,
Yeah.
as we always do on the deep dive, we need to look at the nuances. No study is perfect. What limitations did the researchers themselves point out? Where do we need more research?
Good point. Critical thinking is key. They were upfront about several areas needing more work. First, gender. This study was only on males.
Right.
And there's some previous research hinting that IPC effects might differ between sexes due to hormones or other factors. So studies on female swimmers are definitely needed.
Makes sense. What else?
The timing of the blood samples, they only went out to 48 hours. It's possible they missed the absolute peak of some inflammatory markers or maybe recovery benefits that extend even further out, beyond 2 days. Longer follow-up would be good.
Okay. Anything else?
Yeah, a few other things. Factors like sleep quality, exact hydration levels, detailed dietary intake. These weren't super tightly controlled. And in the real world, those things matter a lot for recovery.
True. Confounding variables.
Could be. Also, these were well-trained amateurs. How IPC affects beginners or truly elite professionals might differ. And the control group used that low-pressure sham cuff. While likely negligible, you can't totally rule out some tiny physiological effect compared to doing absolutely nothing at all.
Minor point, but worth noting scientifically.
And finally, this was a short-term thing, right? 7 days of RIPC. Does it work sustained over a whole competitive season? Does it help prevent injuries long-term? We need longer studies to validate that.
All really important points for future research. It does make you wonder, doesn't it? Could you combine IPC with other things? Like, what if you did IPC and cold water immersion or something else? Could they work together?
That's a great question. Exploring those potential synergistic effects, combining different recovery tools, is definitely a logical next step. See if 1 + 1 = 3, recovery-wise. The potential's there.
Absolutely. So let's try and synthesize this deep dive. The core message seems to be both single and repeated IPC help swimmers recover from tough training.
Yep.
But the really big news is that repeated IPC, done daily for a week in this case, was significantly more effective. Consistently better performance recovery, less muscle damage, better antioxidant status, less inflammation.
That's the main takeaway.
It offers a really promising, practical, and pretty accessible strategy for swimmers looking for that recovery edge.
It really does seem that way based on this evidence.
Which leads to a final thought. If these brief, simple periods of just restricting blood flow can unlock such powerful internal recovery mechanisms, well, what other hidden biological shortcuts might be out there, waiting for us to discover how to optimize performance, recovery, maybe even general well-being?
It's a fascinating question about tapping into our own physiology more effectively.
Definitely something to mull over. We really encourage you, if this piqued your interest, to delve deeper. Read the full scientific article yourself. We'll put the citation details in the show notes.
Yeah, seeing the raw data and the full discussion is always valuable.
And of course, if you found this deep dive as insightful as we did, please make sure you follow the channel, turn on those notifications.
So you don't miss out.
Exactly. So you don't miss our future deep dives into more surprising and cutting-edge topics, just like